Hello, today we have another LeetCodeHard problem, which is count the number of houses at certain distance to. You're given positive integer n, x, and y. Okay. And in a city, there exists house numbered from numbered 1 to n connected by n streets. There is a street connecting the house number I with the house number I plus 1 for I between n and minus 1. So from 1 to n minus 1. Okay, an additional street connects the houses from x and y. Okay, so we have a another additional connection. For each case, such as k between n and 1, you need to find the number of paired houses, such as minimum number of streets that will need to be traveled to each house start from house 1 is k. Okay, so number of the streets is between number of the houses, amount of the houses. Return a one index array result of length n, where result k represents the total number of pairs of the houses at minimum streets. So we have to count connections between houses, right? And this is 6. Okay, so we have 3 houses, 1, 2, 3. Output is 6, 0, 0. Why 6, 0, 0? What is return the one is the result of length, or result k represents the total number of pair of houses, the minimum street required. Okay, so there are one index, so there are 6 houses that can be connected to 1. Okay, so there are 3 houses, right? And 6 of them can be connected by 1. Is there any connection by 2? N minus 1, 2, 3 houses, so I can be 2. K can be 2. Why don't we don't have a house connected by, for example, 1 to 3 house connect directly? Okay, so we have it. It's from 1 to 3, but is it like shortcut connection? Okay, let's take a look at this one. For resistance pair for k equal 1. Oh, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is why k1 is 10. For k equal 2 pairs, okay. And connection between 2 and 4, okay. Okay, so a couple thoughts that we have. So we have to count connections, right? And we have to count connections for specific length. And this length must be, which is k, named as k. Goals. Count connection, unique. Is it unique connection? Is it like 2 and 1, 1 and 2 connected? And okay, so for every so this is for every house. We have to count connection for specific lengths for every specific length, and return it as array. Let's call it G1. Count connection for every specific length. So, and do we have any ideas how we can do it? So result will be our array, right? List of integer. So how we can count connection for every specific line? So what we can do, we can iterate, right? For e in range from 1 to n. This is our I. N minus 1. So, wait, n. So it's 1, 2, okay, 1, n, because n minus 1 is not included, so it will be n. What we're gonna do, we need to so our result array, so idea one, our result array, let's call it hypothesis one, H1. The result array is size of result array will be from 1 to n, initialized with 0, right? Because we have 3 and 3, and we have array of 3. And 5, and we have array of 5. Okay, so, and of n. Then, when we count for every specific, for every house, we count connection. So there is a connection between house and okay, so there is a street connecting the house number house I plus 1. I with the house I plus 1. So I plus 1 will always have a connection. So I with the I plus 1 will have connection. Can I say that, let's call it H2, if I with the house numbered I plus 1, house I have connection with the house I plus 1, does it mean that I can do result I just plus 1? We just add in one connection anyway. So in this case, if we have H1, H2, H3, right? So we're gonna have 1, 1, 1 added. Then if I is less than, but what about X and Y? Okay, so but H3 doesn't have a connection, right? This connection does not exist. So we have to apply condition if I is less than I minus 1, if I is more than 0. So this we are adding right connection. If I more than 0, it sounds simple, but I bet it's not that simple because it's hard problem. So, okay, if I is more than 0, but if I more than 1, because number 1 doesn't have a connection, right? Then we add the left connection, okay? And yeah, and another connection that we have to add is if I equal X, and then we have okay, so the X could be the same, could be equal, X and Y, right? So, and another case, we have to handle HX and HY. Is there anything that X is more than Y? No. We can ensure that by doing swap. So X, if X more than Y, then what we're gonna do, we're gonna swap XY, YX. In this case, Y will be always more, Y will be always more than X. In this case, we were gonna have like this. Okay. So this is a right connection, this is left connection, and this is special X and Y connection. So if I equal X, we have one connection that we add with address I plus equal 1, right? So we have connected to Y. Then if, can I do or I equal Y and I adjust that? Yeah, why not? Okay, and we return res. Okay, this is a fun part. Let's run it for our example here. I really like to run through this one. So let's run it through this one. Dry run. Let's learn how to tolerate pain. Okay. So result we will have this guy. Right? Because n is 5, we have array of 5 with initialized with 0. Now we start from 1. Okay, this is started from array started from 1. Okay. We start from 1, but this array begins from 0. Okay, this is really like, okay. I mean, do I have to add like -1 here? Because it's gonna be, it is from 1, but we know it is from 0. So 0 will always be like 0 because there is no house 0. Or maybe it is. But there is no connection 0. We have to return connections, not houses. So it will be no connection with length of 0. And this is why it's one numbered from one array. Okay, so now we have 5 houses. 1, 2, 3, 4, 5. Right? So we will, and we have x and y. X and y is 2, 4. We are not flipping them, they will be the same. Okay, so for e range from 1 to n, what we're gonna do? If we start with I equal 1, and we go like this, is if I less than 1 is less than 4. Yes, so res 0 will be +1. So we add in 1 here. And we have this connection registered. All right. Then if I more than 1, it is. So we have if I more than 1. No. If I equal x or I equal y, it's not 2, it's not 4, then we go and we change I to 2. So we registered only one this connection. We go into 2, and here we register another connection. If I less than n, 2 less than 4, which is 4, let's do like this. 2 less than 4, go. Yep, we registered this. Then if I more than 1. Now it is more than 1. Then we register this, right? And H2. And if I equal X, which is 2, which is correct, and then we add another connection, which is this one, right? Yes, we register this connection. So it will be 1, it will be 2, and another connection, it will be 3. We move forward and oh, see what I mean? So it's not gonna work. So our result will be, yeah, it's not gonna work because our result will be 1, 2, 2, 2, 3, like this. Which is, we are solving wrong problem. We are counting connection from each houses. Yeah. So everything is incorrect because our problem is we are counting connection for each house. But our goal is count connection for every specific length. And it's not even connection for the house because we can count connection by the houses by doing DFS, right? But the thing is that if houses are all connected, does it mean that I don't need DFS? I already know the length. So for example, if house 1 is connected with house 2 with house 5, right? I know the connection will be 5 minus 1, which is 4. 1, 2, 3, 4. And I increase n4 with 1. Okay. Yeah, I can remove that entire thing. But we should count connections for every specific length. Connections for every specific length. Yeah, I shouldn't write code before I realize I understand it. Yeah. Okay, I'll probably delete everything except this drawing. I really like it as key. Okay, solving the wrong problem. Now, so I still have to do for iteration, right? In range from 1 to n. However, in this case, I know like for if I'm on a house 1, I know there is a connection, and there is a 4 connections between 1, between 2, and between 1, between 3, between 4, and between 5. So for house 1, I got 4 connections already with a different lengths. So this is 1, this is 2, this is 3, this is 4. So I can say that connections, let's call it connections. I like it more. It means more clarity. I made this mistake because I call it res. So connection I equal n minus y. So we get all this pair 1, 2, 1, 3, 1, 4. But this is connection 1. What is the range for connection 1 range? Connection 1 can be between 1, 2, 2, 1, okay, 2, 3, 3, 2, 1, 2, 3, 4, 5, 6, 7. Is this a combination, right? So if we have a 5, do we have a combination like n multiplied by n minus 1 divided by 2? So if you have a 5, we don't have to have unique. So 1, 2, and 2, 1 exist. So if you have a 5, 5 by 4, 20, 10. Oh, this is precisely 10. That's interesting. And we cover all one's connection, right? Automatically. Now 2. For 2 we have 1, 2, 3, 4, 5, 6, 7, and 8. 10, 8, 2. 1, 2, 3, which is 6. 1, 2, 4. 1 and 4 connected. Oh, this is a point of this bridge because it's breaking all maths, and we have to. Okay. All right. Anyway, it was great attempt from me to solve this hard problem. It was a great mind exercise. Thank you for watching, and thank you for the task. Bye.